before we get started on Roman numeral 8 and Roman numeral 9, I ask you a question about bromothymol blue. If you put it in an acid, it turns yellow. If you put it in a base, it turns blue. What's the neutral color? So here's what's going on here. Blue, base, yellow, acid, and very light green is in the middle. So green is your answer on that one. So acid, bromo turns yellow, base, bromo turns blue, and then neutral is green. That is the answer. So in the last video on acid-base, Roman numeral 6 was indicators, Roman numeral 7 was single replacement reactions when you put an acid and metal together. Roman numeral 8, neutralization. I like this. I think double replacements are easier than single, and this is a double replacement reaction. But this is perfect. So here's the deal. You eat a bunch of chili for lunch, and you start getting a little upset stomach and you get heartburn. Heartburn isn't your heart burning. What that means is your stomach is acidic, but since it has a mucus lining around it, you can't feel it in your stomach. Heartburn is when some of that acid seeps up to your esophagus, because your esophagus isn't lined by mucus, so it starts burning the lining of your esophagus. That's heartburn, okay? And the way to get rid of it, you take an anti-acid. So, what acid is in your stomach? Hydrochloric. Oh, by the way, we're leaving number 1 blank because we're going to fill that in later. So in your black notebooks, you should have Roman numeral 8, neutralization, number 1, leave blank, and then number 2. So I've got the HCl in my stomach, and I'm going to use a little milk of magnesia. Milk of magnesia is a base, and it's magnesium hydroxide. So, that's what it looks like. Hydrochloric acid plus magnesium hydroxide. And don't forget to do your charges. Now, this is a double replacement reaction. So the H and the Mg, they flip-flop. So here's what I get. I get Mg hooked to Cl. But Mg is a +2, Cl is a -1, so it looks like that. So MgCl2, that's magnesium chloride. That's not an acid, that's not a base, that's a salt. Now you're going to hook the H with the OH. So we have this. H plus, OH minus. Don't forget, when you do double replacements, you don't take crisscross products over there. Now, for those of you that understand this stuff, HOH is water. So, when I put an acid and a base together, I always get a salt and a water. That's neutralization. So for number 1, you're going to go like this. All right. So obviously, you're going to have some questions to email me about neutralization. But we didn't balance this thing yet. So we got to balance it. Well, there's 2 OHs. There's only 1 OH there. So we got to put a 2 there. Once we put a 2 there, we got 2 OHs, but we got 2 H's. So we only have 1 H here, so we have to put a 2 there. But that means we have 2 Cl's. But if you look over here, oh look, we got 2 Cl's. That's balanced. We're going to do 2 more of these, and then you are going to have to do 2 to email into me. Okay, so don't forget, acid and base, look at the arrows. It really yields salt and water, very little acid base left. So that's how it works in your body when you take an anti-acid. The acid in your stomach reacts with the base and the anti-acid, and you make salt and water. Okay, and hopefully the heartburn is gone. Here's your next one. Number 3. Okay, now don't forget, you have to put your charges up. Because if you put your charges up, the charges stay the same on the other side, which is really nice. Don't forget, see that 4 right there? It's in a polyatomic ion. That goes over there. But that 3 does not, that's a crisscross product, and that 2 does not, that's a crisscross product. So don't bring crisscross products over, just the ones in the polyatomic ions. All right, double replacement. Calcium is hooked to that. So I get Ca plus 2, then PO4 minus 3. That absolutely doesn't equal 0 for the oxidation states. Crisscross, you got a 3 here, you got a 2 here, and then always you have HOH. Don't forget that 3 from the H doesn't go over and that 2 from the OH doesn't go over. So there is your equation. Now you got to balance it. So you're looking and you got 3 calciums. Let's start there. 3 calciums. So I'm going to put a 3 here. Now you have 3 calciums, but look how many OHs I have. 3 times, I got 6 OHs. I only have 1 OH over there. I'm going to have to put a 6 over here. Now once I put a 6 over there, that means I got 6 H's. If I look over here, I only got 3. But if I put a 2 right there, then I'll have 6 H's. And then I have 2 phosphates. But if you look over here, bingo, you got 2 phosphates. Everything is balanced. Acid plus base yields salt plus water. All right, we're going to do 1 more, then I'm going to give you 2 to do. All right, this will be an easy one. Hydrofluoric acid plus lithium hydroxide. Well, the H is positive, fluorine's negative, Li is plus. Don't forget, if you detect a polyatomic ion, put it in parentheses, and that's a minus. So, this is going to be a real easy one. The lithium hooks up with the fluorine, Li plus, F minus. So it's a positive and a negative, that equals 0. We don't have to do anything with lithium fluoride. Plus we get HOH. That's a plus, that's a minus. Remember, that's water, but it's easier doing it this way for balancing. So everything is balanced. Acid plus base yields salt plus water. All right, those are 3 examples. Now I'm going to give you 2 to do, and you can email these 2 to me. Number 5. Now, that's aluminum hydroxide plus sulfuric acid. Don't forget, if you detect a polyatomic ion that's not in parentheses, put it in parentheses. It's easier to make the products over there. And find your charges. So your charges go over there. Don't forget that 4 will stick with the SO4, but the 3 and the 2, they're crisscross products. You don't bring them over. So that's the first one I want you to do. Number 6. Nitric acid plus barium hydroxide. So that's the second one I want you to do. And don't forget, if you detect a polyatomic ion, put parentheses around it. Like I said, it's easier to balance and make the products over there. So these 2, I want you to do those 2 out, get your salts and waters, balance them, and then email them to me. So that is neutralization. Okay? And that was Roman numeral 8. Now, Roman numeral 9 is the exact opposite. It's called hydrolysis. Hydrolysis means adding water. So if neutralization was acid plus base yields salt and water, if hydrolysis is the opposite, well, for number 1, salt plus water yields acid plus base, but look at the arrows. Usually salt and water stays salt and water. A little bit does break up and make acid and base, but it's the exact opposite. This is a little bit harder than neutralization. Okay? Now, I'm going to give you 3 problems. We're going to do 3 problems on the board, and then I'm going to give you 2 to do to email me. So you're going to have a total of 2 neutralizations to email to me and 2 hydrolysis to email to me. Okay? And then you'll have some questions in your packet and in your review book, but don't put them in the emails. We'll go over them. All right, so number 2. Now, obviously this is the salt. There's no H in front, there's no H in the back. That is potassium carbonate plus water. But I don't like, what's easier for you is when you're doing hydrolysis, don't put H2O down, break it apart. It's much easier for a double replacement. And when you break it apart, instead of writing H2O, I want you to write that, HOH. That way you can break them apart easier. Okay, so we're going to do the same thing. This is a double replacement. but you got to find the charges on this. So potassium's group 1, that's a plus. I detect a polyatomic ion. I'm going to put parentheses around it, and that's a -2. Now, we are ready to go. So, remember a double replacement, you just flip-flop. So in other words, that K is going to flip-flop with the H. So the first thing we're going to get is KOH. K plus OH minus. There's your base. Now don't forget, you do not bring that 2 over because that 2 is a crisscross product. You definitely bring the 3 over because that's part of the polyatomic ion. All right? So, we have KOH, which is a pretty strong base, potassium hydroxide. And then the next thing is we use that and that. Now we got to use that and that. So now I have H plus and CO3 -2. Well, a plus and a -2, that doesn't equal 0. So I got a crisscross. That's going to be a 2 there. So that is hydrolysis. We're going to do 2 more, but we got to balance this crazy thing now. So the first thing I look at is there's 2 Ks. So we got to put 2 in front of the K. Now there's 2 OHs. There's only 1 OH there, so I'm going to put a 2 right there. Now there's 2 H's. But if you look over here, there's 2 H's. 1 CO3, 1 CO3. Everything is balanced. Okay? All right, we're going to do 2 more of these. Remember, this is going to be water, but I'm going to make it this. Now, what the heck is this thing? Well, there's no H in front, there's no OH in back. It's a salt, but this is called aluminum acetate. Aluminum acetate. All right, so now, the little arrows. And now remember, we got to find the charges. Well, you already know the charge for H is positive, the charge for OH is always negative. Aluminum, when you look it up, is a +3. Acetate, -1. So, we got to hook things together. So the aluminum, the plus is going to be switching with that one. So the aluminum is going to be hooked up with the hydroxide. So we have this. Al plus 3. OH -1, that does not equal 0. Crisscross, that's a 3. Now we got to hook the H up with that thing. H, C2, H3O2. H is positive, the acetate is negative. Okay? Don't forget, it's a double replacement. I don't bring that 3 over, that's a crisscross product, but I bring the 2, 3, and 2 over because it's part of the polyatomic ion. Now we got to balance this crazy thing. So, I got 3 of these, so we might as well start here. Got to put a 3 there. Now I have 3 of those, but I got 3 H's. I only have 1 H here, so I'm going to put a 3 here. That means I got 3 OHs, but look, I already have 3 OHs, 1 aluminum, everything's balanced. Okay, that's your second one, that's your second hydrolysis. Now, we're going to do 1 more hydrolysis, then I'm going to give you 2 to do. Okay, so there's my salt, barium nitrate, and there's my water. Now, barium nitrate, barium is in group 2, which means it wants to lose 2 to look like the noble gas configuration. So we have a +2, nitrate is -1. We got the other ones okay. So now double replacement, the Ba takes the place of the H, so the Ba is hooked to the OH. Ba +2 OH -1 crisscross 2. So that's barium hydroxide. Now the H got to be hooked to the NO3. H is a plus, NO3 is a minus. We don't have to do anything there because a plus and a minus equals 0. Now, this looks like a pretty easy one to balance. There's 2 NO3s, so we're going to put a 2 right here to make out 2 NO3s, but that means there's 2 H's. We got to put a 2 here. We got the 2 H's, but that means there's 2 OH's. But, oh look, we got 2 OH's, and it's done. So, there is your third hydrolysis. Now, I'm going to make up 2 for you to do and email to me. All right, so you got 2 neutralizations to do and balance. You have 2 hydrolysis to do and balance. Then you have a few questions in your review book and in your packet, and you're good. All right, here's the first question. So, your first question is sodium phosphate plus water. So on the other side, you have to make, usually the base goes first and then the acid, but I don't care. That's the first one, then make sure it's balanced. Your second one is ammonium carbonate. Don't forget my rule. If you detect a polyatomic ion, put parentheses around it. Find the charges of everything. I already found the charges of that, so just find the charge of ammonium, find the charge of carbonate, and then make your base and your acid, and then balance it. So you've got 4 problems to do. All right? And this was Roman numeral 8 and 9. We only have 3 Roman numerals left, and we'll be done with the chapter. Okay? All right.